So before we start going through that marker's coming around, so make sure you mark yours. Okay, so let's figure out the rest of this week first. Today's Tuesday, so for the most part, we are finishing the unit today. Okay, we're going to go over the homework. There's another assignment. Now, Wednesday, if you did not complete the quiz yet, you will be given it during class, or if you are coming in some other time between today and tomorrow this class, then you can do it then. So if you're taking a quiz in class, I will of course have everything recorded for you. So I will pass back the quiz 2 and go over it. Now, hopefully all of you kept quiz 1 and you will keep quiz 2, and those will be study guides, and you will use them on the take-home test. I will then give the take-home test at the end of this period and would like you to work on that take-home quiz. I want to give you the opportunity to take out that take-home test over a longer period of time. So Thursday, you will do the take-home test during class with each other. I will not be here on Thursday, so there'll be a sub. So hopefully you bring all of the take-home tests back. If not, the sub will have copies made as well, just in case. And then on Friday we have our test. Okay? Now, let's kind of review a few things, just so we're back in the game, make sure we're good. Take-home test, use any resources you want. You can use my videos, you can talk to each other, you can talk with your tutors, or you can just work with each other or outside of class, other students. Doesn't matter. You just really can't ask me how to do a problem. I can give you limited guidance, but the nice thing is if I have a sub in here and that sub has some sort of a math mind, which sometimes they will, sometimes they won't. You're swimming, so you should not expect it to catch you. But, so does that make sense? Take-home test. I grade each problem for right or wrong. There's no partial credit. Okay? So hopefully you get them all right. The take-home test is worth a small portion of your overall test grade. So those of you who are like, oh, I'm just going to make up numbers, and look, you got a 0 out of 30 on the take-home test, that's going to have a negative effect on your test. So you have the opportunity to do an awful lot with that. And then Friday we will do our regular test. Is that okay? Everyone kind of clear what we're doing? Cool. So tomorrow I will give you the take-home test at the end of the period. I will remind you to please bring it back on Thursday. That way, Thursday during class, you can work with each other. I will tell the sub that you can use your phones to get onto my videos, stuff like that. Cool? Yeah. Everyone like that? And take-home test will indeed be graded for right or wrong. It's not partial credit, so yeah.
I might not be here tomorrow.
Thursday, the sub will be here. Perfect.
Why won't you be here?
I am a judge for the Future Business Leaders of America conference. It's a statewide conference. Yeah.
I know you said this, but just to make sure, if we don't have an opportunity to come in before school or 1 through 4, we're able to take the test tomorrow.
I will during class. Yeah.
Okay.
So what I will do is, because I'm going to go over the quiz in class, I will put you in an alternative location. Because just probably wouldn't be that fair. If I'd be all noisy and talking about the quiz, and you'd be like, "Sweet, number 3." Oh yeah. That cool.
Got it.
And
Yeah.
that will also be recorded. So I will record that. So if you missed, you have the opportunity. If you missed because you were taking it, you have the opportunity to go back through and watch the video to clarify for review. Is that cool? Everyone happy? All right, let's take a look at. So let's see. There was 2 equations we're going to use. No, that's not what I wanted. I want to use y plus for growth and a minus for decay. So growth means it's gaining value, decay means it's losing value. We talked about this yesterday. Okay, so that's the equation that we're going to use over and over and over again. Just to make sure we know, this is like your initial start, your starting value. Okay, so it's like, hey, we're going to buy a car that costs $40,000 and it'll depreciate. The $40,000 would go there. The 1 stays as a constant. If it's growth, you would add 1. So your percent needs to be made a true decimal. And then T is just your time. Now, if the problem says, hey, time in years, then T is time in years. If T is a time in seconds, then it's time in seconds. If your T is time in minutes, then it's time in minutes. If T is time in hours. So there's a lot of times when you're doing if you're doing science experiments of some sort, I think in biology, a lot of times classes do something called a fruit fly experiment, which means you start with 4 or 5 fruit flies in an enclosed case that has air. There's a couple droplets of sugar water as their nutrition, and what you do is you go in, you're like, okay, start out with 6 of these guys in here, and you put it in some place. You come back the next day and you go, oh, look, there's now 16 of them in here. And then the next day you come back, oh, look, there's now 58 of these in here. And you're trying to count them, but they're moving around like the speed of light. You're like, 1, 2, 3, you guys stop moving. And then usually the last day you put them in a deep freezer or something so they kind of expire, and then you can count them all up. And the carcasses of fruit flies. Don't worry, they're little tiny things. So, I don't know if you do that experiment or not in biology, but you might. But that would be an exponential growth type of scenario. If you introduce something to a large population of flies and you introduce something into as an experiment that would perhaps lower their breeding capabilities, you could then see exponential decay. Okay? All right, so problem number 1 says you deposited $40,000, is that right? Into an account earning 6% per year. How much money will there be after 15 years? So you have 40,000. So let's just write our values down. 6%. And how many years? 15 years. Okay. So we have enough information to definitely apply to these problems. So I'm going to use my equation. That's just a general equation. Why is this one going to be plus R? Yeah, it's growing in value, right? Everyone comprehend that okay? All right, so let's make sure we understand where everything goes. So my A values here, so I get Y equals 40,000. 1 plus, I need 6% to be a true decimal. Is it 0.6 or is it 0.06? 0.06. So careful on that, because that's definitely an error people will make. So to go from a percent to a decimal, you have to move the decimal 2 places to the left. Okay? So now it's going to be 1 plus 0.06. And then my time is 15. Now, it's up to you if you want to go 1 plus 0.06 and get 1.06. Because you have the calculator to do this, and I'll bring the fancy ones in on. Yeah. Cool. Let's see if we can do it. Ready? 40,000 is the first thing we plug in. Is that right? And then I do an open parenthesis, which is the key right above the 8. And it's 1 plus 0.06. 1 plus 0.06, close the parenthesis. Is that okay? Then I'm going to use the caret key. The caret's right above the division, so it makes an exponent. How many years were we doing this for? 15. Okay, hit enter. So your $40,000 after 15 years is worth $95,862.33. Yeah. Did it work for you? Is your answer match mine? Oh, perfect. Yeah. Not everyone has that. But perfect. So you have a good subroutine, so you're perfect. Good deal. Just what'd you round it to? Nearest dollar? So what I would have done is I would have made 95,862.33. Okay, 2 decimals because it's in cents. Yeah. Why did I get the what? Oh, it's always a constant. It's always there. It's going to be 1 plus. It's always remains. And for decay as well, it's 1 minus on decay. Okay? Hey, so is that something, like if you came across $40,000 that you knew you didn't have to use for 15 years, do you think that'd be an okay thing to do with it? I mean, 15 years, the hard thing is you're all 15 years old. So it's like, oh my gosh, high school's been forever. But, you know, honestly, when you get to an adult 15 years, you're just like, oh, wait, where'd that go? It's quick. But, so as an adult, if I knew I had $40,000 available and I knew I had the opportunity in 15 years to more than double it, I might look at that. Okay? Does that make sense? Cool. All right, let's try the next one. Is that okay? So problem number, so everyone feel good about this one? Do I have to write the number in here? It's on the video. All right, problem number 2. All right, problem number 2, we say that a diamond ring is worth $8,000 and is expected to appreciate, so it's going to increase in value by 7% each year. Find its value in 20 years. So it's an $8,000 ring. It's going to appreciate how much? 7% per year. And how many years are we doing? 20 years? All right. So we're going to go back to our equation. Y equals A 1 plus. Hey, why is it plus in this one? It appreciates, going up. Okay, so 8,000 goes in for A, so I get Y equals 8,000. 1 plus 7% is a true decimal is what? 0.07. Be careful. Remember, it's always moving 2 places to the left. So 1 plus 0.07, and that's raised to the 20th. Okay? And again, I can plug that into my calculator as well, and I can come out with a value. So let's plug it in. So I'm going to get Y equals 8,000. Open parentheses, 1 plus, what was my percent? It was 0.07. And then how many years we're talking?
20.
Raise it, use the caret, raise it to the 20. Okay? So your $8,000 ring is now worth $30,957.48. Huh. That's not a bad investment. I mean, I guess if you buy and sell diamonds, right? I mean, I guess how society is. People are like, dude, I'll be divorced in 20 years. That'll be sweet. I get a $31,000 payout for my ring. I'm just saying, you know, society is that way. Okay. Is that okay? Problem number 3 says a computer server and network system are estimated to be worth $58,000 and will depreciate. So is it gaining value or losing value? Losing. Depreciate. It's losing something. Okay? At a rate of 9% per year. Find the value 5 years from now. Okay. So problem number 3. How much was it? 58,000. What's our percent? 9%, which will be indeed 0.09. Some of you are a little ahead of me. How many years are we talking about? 5. Okay. So it's gonna be worth less than $58,000. It's depreciating. Agree? Okay. So our equation, y equals a, and it's 1 minus. So why is the minus there? It depreciates. You lose value. This sign changes. This is the exact same equation, except that sign changes if it's depreciating. If it appreciates, you make it a plus. All right, so I have y equals 58,000. 1 minus 0.09 raised to the 5. Wow. Okay. Is that good or bad? I don't know. All right, so I'm going to go 58,000. 1 minus .09 was it? Raised to the what power? How many years? 5 years? Okay, now let me ask you something. If you work for a business, do you think you might go and buy a computer system? I mean, school district does. School district spends an awful lot of money on computers. Okay? You know those Chromebooks that we have out there? We're replacing all those. Some new tablet. I don't know. Soon. No, like within the next month or so. Yeah. So they're switching those up. Do you think we could sell those Chromebooks back to somebody? Yeah, probably for like 11 cents a piece or something. I mean, they probably depreciated pretty good in value because those Chromebooks, they're not. They serve their purpose, but they're really not that good of a computer. Self-destruct. All right. So we'll be worth less. So it looks like your computer system would be worth $36,193.86 after 5 years. Okay, because it's losing value, right? What are some things that a company might do? If you bought a computer system and it's no longer adequate because your business got too big, you might get a credit from the company you bought from as long as you're buying an upgraded version of their computer system. It's called prorating. They do it with tires a lot. Okay, I don't know if you ever been with your family when they had to get tires. And they're like, oh, these are 60,000-mile tires, and you've only driven 37,000. So they prorate what your tires were. So then it's like, okay, this tire would have been $120, but because we're prorating it because you didn't drive the whole thing, then it's going to be, you have to pay less for your tires. I mean, just a way to think about it. All right, problem number 4 says a concrete mixing truck has a current value of $333,000. It depreciates at 6.5% per year. Find its value 8 years from now. So a cement truck. It was worth $333,000 at the time. 6.5%, was that right? And then how many years? 8 years. Okay. Now, here's kind of the gotcha. And I'm going to make sure this isn't on the test, but I just want us to think about this. That percent has a decimal in it, so is it converted to a true decimal? No. How do I convert 6.5% to a true decimal? Move it left, so I get what? 0.065. Good. Thanks. Cool. All right. So 6.5% converts to 0.065. Okay? All right. Is it losing value?
Yes.
Yeah. So we're going to have the minus sign in there, right? So I get y equals a 1 minus r raised to the t 333,000 1 minus 0.065 raised to the 8. That's going to be how our equation is. Think this is something that a company that deals with cement might look at? Sure. Do companies that do cement, do they sell their old cement trucks to other companies? Probably. I mean, a lot of times they run those things to the ground, so it's like, yeah, you need to put like $90,000 work into it, and people are like, put it in the junkyard. All right, so let's figure this out. It's 333,000 1 minus 0.065. How many years? 8 years. Hit enter. It looks like our $333,000 bad boy is only worth $194,507.84. Round to the nearest penny. So it's lost value. Would that make sense? Should it lose value? Sure. If you use something, should it use value? Depending on what you use.
I'm trying to think of a case where if you use something and then it increases value.
just like our normal everyday, like your clothing's gonna lose value, right? The hamburger meal you buy over there at the McDonald's definitely lost value. It's like, oh, it's got 6 bites out of it. Would you want to buy it for more than I paid for it? Yeah. Now I realize every now and then you bring food back to campus. People are like, dude, I'll give you $5 for that sandwich you paid $1 for. All right. That's called entrepreneurship. That's good sales technique. I've seen that way too often. Dude, you bought French fries from Sonic. You got the taters. I'll give you $20 for them. I can start thinking to myself, dude, I'll run over. Just be good for a few minutes. I'll be right back. $20 for tots. All right. Number 5, we're almost done. You are excited to buy your new bright red Ford Mustang for $31,500. You heard its value will depreciate at a rate of 7% per year. When you finally pay the car loan off in 4 years, how much will your Mustang be worth? Okay, so that last sentence, does it really matter that it takes us 4 years to pay off our car? No, they're just saying, hey, after 4 years, what's our car worth? Okay, so problem number 5, Mustang. All right, so we're buying this fancy car, $31,500. Yay, life is good. It's going to lose 7% per year, and we want to know after 4 years, what's it going to be worth? So, again, depreciation or is it increasing? It's going to lose money. So it's 1 minus. Okay, so 31,500. I guess we'll go y equals.
You just made that one? What? I'm saying, where's 5?
Was it 5?
Oh, I'm sure. I thought you already did 5. That's
Yeah, I'm doing number 5 right now. 7% as a true decimal is what? 0.07, okay? So 1 minus 0.07, and that's raised to the t value, so that's a 4, okay? So it's losing value. It's going to be worth less than we paid for it. That makes sense. Because we're going to drive this 31,000, is it 31,500?
Yeah.
And it's going to lose how much? 7? And how many years? 4 years? So our $31,000 bad boy is only worth $23,563.64. We rounded to the next penny. Okay, that actually held pretty good value. That's pretty good value for a car.
especially for 4 years.
So, what do you think? Is this concept? It's newer. It is so very completely related to the exponents and growth and decay that we've been working on. Okay? But I want to share with you all this. So this test, I think, if you truly look at the old quiz, and the video's on it, online, and then when we go over the quiz tomorrow as well, and look at that video, and then you apply that information to the take-home test, and you try and do the best you can on take-home test, you have all of that in place. I think when you walk in on Friday, you're going to be very prepared for this test. Okay? I took the test this morning. It took me less than 5 minutes to do it. Yes, I understand I'm the teacher, but what that basically means is I take however long it takes me, multiply it by 10, and that's how long it should take the longest student, even if that student has time and a half. I'd say most of you would probably get this test done in less than 30 minutes. Okay, if you have applied yourself. You're like, oh, I have to try and remember how to do each and every problem. Well, you didn't prepare appropriately. Okay? So, if you would, please make sure your name is on that assignment and any other assignments to pass those forward. And then I would like you, and I think you'll like me for this as well. So page 35, the 36, the back side of it's blank. So if you have the rest of the period to work on page 35, okay? If you don't have your book with you, go take your phone, take a picture of your friends, and then just jot it down in a separate book, okay? But that's all I have for you. And then just a reminder that tomorrow I will give the take-home test at the end. So that's Wednesday. And then Thursday, I would like you to work on the take-home test. During class time, I won't be here. You hand. So that's a day for the sub. You do the take-home test there. Don't worry if you forget it at home. They'll provide you an extra copy. And then Friday, you need to hand in your take-home test. Take-home test. Follow that, THT. Take-home test. And then we have our in-class test. That's our ICT. Oh, all about the acronyms. Everyone feel pretty comfortable about this? Everyone know what I want you to work on now? Page 35, please. Cool. Now, get those done.